Alright guys, so let us see how we can maneuver through some of this section 3 and section 4 stuff of chapter 5 by looking at some of the text, and then I plan on using a different feature to kind of show you a couple problems worked out that may help. I do want you to be aware that there are other opportunities for videos. Um, let's see what y'all's look like on your WebAssign. When you go into your WebAssign, at the very bottom left, you should have access to some resources. And so you can actually look at some of the videos that they have from the different sections. So I'm going to advise you to look at these of section 3 and section 4. And those should be some help to you. Again, I'm going to provide some where I kind of show maybe a step-by-step.
My name is Laura, and in this video, I'll be telling you how to find a partial fractions decomposition.
Okay, so I think I was showing y'all where the videos were, but again, just down in here, look at these videos, and then I'm going to send some other videos of some problems worked out. But if we go to our text, we'll see that there's some of these opportunities of using partial fraction decompositions. In this case, we would divide out because we have an improper, and we're left with a piece when we're doing this, that we can integrate this piece and we can integrate this piece by using a substitution. So that's kind of what we did in the last class. Looking at another one of these examples, here's one that they did a partial fraction decomposition, and they're left with this. Now this one's a little different. So we have these different things. This one we can integrate. This one we can integrate because we'd have u is x minus 1. The derivative of u would be 1. So we could get rid of this 2 up here. So we'd have a 1 over u squared. This one, if we integrate, we'd have an x squared plus 3 as our u. So we'd get a 2x as the derivative of u. This one would not work because I have an x minus 1 up top. I'd have to split those two things up. So I'd have an x over x squared plus 3 minus a 1 over x squared plus 3. I'd have to split up those two fractions. And then it becomes, how do we integrate a 1 over x squared plus 3? So in the text they talk about completing the square and the process of completing the square. And so we'll kind of look at an example. I think I had something similar to this that we are going to look at, where what's going to happen is we're going to end up with something that we don't know how to integrate. Right, so we're going to have to use a different technique. The technique that they use, again, maybe the only technique, is by completing the square. We get something squared plus 1 on the bottom, because what that does is turn it into an arctangent. The integral of a u squared plus 1 is an arctan, or 1 over u squared plus 1. So it's going back and looking what is the derivative of an arctangent. So we'll look at a problem that involves that. Also want to look at a couple of the ideas from section 4. Again, these are our Pythagorean identities that we've come close to in 172. So there are some different substitution techniques. So if you have a sine and a cosine being multiplied by each other, given the proper exponents, we can manipulate that cosine squared, and there's a cosine, to turn into a 1 minus sine squared. This, now we can do a substitution. Let sine of x be equal to u, and then the derivative of u will be the cosine x dx. So we'll have a way of substituting that out. We can do the same for these with some of our secant terms and tangent terms. All depends on what we're trying to factor out. They have, or substitute out, they have this little rules down here for us pending what we're given, what we should choose as our u, depending on the exponents for our trig functions. So we will look at an example of that. Something else they have in section 4 is this power reducing formula. I know in 172 we talked about it. You know, how do we integrate this? Well, we turn it into a cosine, and then we can integrate this. What happens if it's something to a higher power? Well, we have to make sure that we're not dealing with any products of trig functions of our cosines. So we'd have to use some of our power reducing formulas. So we'll look at a problem with that. And then lastly, a couple rules here is with secant and cosecant using integration by substitution. So it'll walk you through some of these problems on how we get to these nice formulas. But in essence, what we're doing is we want our dv, when we do the integration by parts, to be a secant squared, because we can go backwards and say that's tangent x. And so by doing that, this is a secant to the fourth x. We get a secant squared x. Tangent x is our u times v. And then we get a v du. So that gives us this thing, which we have a little bit more manipulation to do from here to solve this. So that's something that we'll play with in one of the hand worked out problems. So this is what we're going to talk about, is the section 4 stuff. This is just kind of a video of the 3 and 4 stuff, the 3 that we haven't covered and the new 4 stuff. What I'm going to do is some practice problems using a different capturing system. And so we're going to see how this works out to see if y'all can see the problems that I'm doing and if it's going to be helpful or not. But hopefully just kind of talking about it is just bringing up some things to the past, these trigonometric identities, the substitution. Again, we're just manipulating our expressions. So let's see how the other part works out here in a minute. And that was my daughter Sophie. But I will make those videos here shortly.